Welcome to this webinar module, part of the project Upcast. Today's focus is on supporting and enhancing dataset discovery, with a spotlight on the Resource Specification plugin. You'll learn how an LLM-enhanced data profiling pipeline can be used to extract high-quality metadata for published datasets, boosting discoverability and reuse across domains. Your speaker is Phil Tin from Syntef. Let's get started. LLM-DAP offers a powerful, domain-agnostic solution for automated metadata generation using large language models and retrieval-augmented generation. It ensures consistent, high-quality metadata aligned with domain ontologies, boosting dataset discoverability across sectors. Developed by Syntef, in collaboration with the National Hellenic Research Foundation, LLM-DAP is open source and ready for adoption in a variety of use cases. In this session, we'll introduce the tool and explore why this topic is especially relevant for small and medium enterprises. Then, we'll walk through the plugin module and dive into a live demo. You'll see a real-world SME case study in action, followed by key takeaways to bring home. Finally, we'll wrap up with further reading and resources to keep you exploring. In today's digital economy, operations, products, and services are becoming increasingly data-intensive. This shift is driving the need for broader access to data resources, both within organizations and across external platforms. However, many existing data portals fall short. Their asset annotations often don't align with the taxonomies that matter most to business users, making it harder to find and use relevant datasets. As the complexity of data grows, so does the need for richer metadata. It's no longer enough to rely solely on quantitative descriptors like file size or format. Datasets of interest, especially in fields like life sciences or manufacturing, require semantic profiles that are aligned with domain ontologies. These profiles include detailed descriptions of processes, such as gene sequencing procedures, which are critical for human understanding and machine interoperability. For small and medium-sized enterprises, this presents a challenge. They need solutions that are not only powerful but also accessible, both in terms of cost and ease of use. That's where LLM-DAP comes in. LLM-DAP is a lightweight, user-friendly, and open-source tool designed to help SMEs automate the generation of semantic profiles. It reduces the human labor involved in metadata creation and ensures that the output is aligned with standardized vocabularies. By doing so, LLM-DAP empowers SMEs to participate more fully in data ecosystems, improve discoverability, and enhance collaboration across domains. It's a practical step toward making high-quality metadata generation scalable and inclusive. The LLM-DAP plugin module is based on a framework consisting of 5 main components, each playing a critical role in transforming raw data into rich, searchable metadata. First, we begin with auxiliary data referencing. This component allows the system to incorporate supporting data, such as domain-specific glossaries or external knowledge bases, that can enhance the relevance and accuracy of query results. It's especially useful when the original dataset lacks sufficient context. Second, we move to document indexing and embedding. Here, documents, whether reports, publications, or any textual record, are split into manageable chunks. Each chunk is then converted into a semantic vector representation, allowing the system to understand and compare content based on meaning rather than just keywords. Third, we have context retrieval. When a user submits a query, the system compares it against the stored vector embeddings to identify the most relevant content. This step may also draw on auxiliary data to refine the results, ensuring that the retrieved context is both accurate and useful. Fourth, we reach the core of the pipeline, the LLM-based query. The language model receives a prompt that includes both the user's target query and the retrieval context. Using this information, it generates rich metadata that can significantly improve dataset discoverability. Finally, we have pipeline configuration. This component allows the system to adapt to different use cases by selecting appropriate models, prompts, and settings. Whether the goal is cost efficiency, domain specificity, or hardware compatibility. This step ensures the pipeline is optimized for the task at hand. The pipeline accepts a variety of inputs, including structured data schemas, textual documents like internal reports or external publications, and datasets from repositories. These inputs are processed to support three key use cases: data profiling, data search, and data exploration through Q&A. Together, these components form a flexible, scalable solution for semantic metadata generation, making LLMD AP a powerful tool for organizations looking to enhance their data assets. Here, we will show how both the data provider and the data consumer can use LLMD AP for data profiling and sharing, using an example drawn from the biomedical domain. LLMD AP is a streamlined application that bridges biomedical data providers and consumers through large language models. It supports two primary user roles. Providers can upload scientific papers and automatically generate dataset metadata, while consumers can search and query datasets using a natural language-based interface. The application is powered by a modular architecture. At the core is a Streamlit-based user interface that connects to back-end LLM pipelines, a metadata database, and public biomedical APIs. This is the LLMD AP app user interface. It provides 4 different modules accessible from this sidebar or from these buttons. Let's walk through each of them to see how the system works in action. We begin with the provider, which is designed for users who want to register new datasets using scientific literature. The process starts by uploading a paper. You can upload a local file like this, or you can paste the URL of a file like this. Or finally, you can simply test the PubMed ID as a paper. Next, you can upload a schema. Here, we'll just use the default one. Finally, choose the model and run. After a few seconds, the results are ready. Here you can see the output JSON file. This contains the generated metadata for each field in the schema. In addition, for each field, it shows which part of the paper was used as evidence in the generation. This file is editable, so you can change any field if you're not satisfied. In this case, we might want to be a bit more specific in this first field. Finally, you can save the paper to the database. Now let's explore the Dataset browser. This is the gateway to all of the indexed datasets. Here you can look through the existing entries and view their metadata. And you can use the search bar to filter the datasets by keyword, like this. To initiate a question-answer session, select the relevant datasets and click Ask Questions about selected datasets. Next is the Consumer Q&A page, where users can interact with datasets in natural language. These are the datasets we just chose, and you can ask questions about them here. The system sends you a question and context to the LLM, which responds with an answer like this one. We can keep asking questions here, and the history of the conversation is displayed, making it easy to follow. Finally, let's take a look at the configuration settings. Here you can choose which model to use from OpenAI models or local models. You can change settings like temperature and maximum mounted tokens. You'd also change some profiler settings or modify the prompt template. Welcome to this case study on eNeos and the role of LLMDAP in advancing genomic data analysis. eNeos is a bioinformatics company specialized in analyzing genomic datasets in collaboration with research institutions. Their mission is to identify target genes that can inform downstream applications such as drug development, diagnostics, and personalized medicine. This work is highly data-driven, requiring access to diverse, high-quality datasets that can enrich and validate gene identification efforts. However, one of the major challenges eNeos faces is the efficient identification of relevant datasets from external sources. While public data portals like ArrayExpress and CBioPortal offer vast repositories, They often document datasets using inconsistent vocabularies and metadata structures. This lack of standardization makes it difficult to compare datasets, extract meaningful insights, and integrate external data into internal research workflows. This is where LLM-DAP adds significant value. LLM-DAP is a lightweight, open-source tool designed to help small and medium-sized enterprises like eNeos systematically profile datasets using a user-defined metadata schema. This schema can be tailored to include the specific information that matters most to their research, such as experimental conditions, cell lines used, timing of sample collection, and equipment specifications. These details are often poorly documented or missing entirely in existing data portals. By leveraging LLM-DAP's LLM-enhanced data profiling pipeline, eNeos can automate the extraction of rich, ontology-aligned metadata from both internal and external sources. This not only reduces the manual effort required to curate datasets, but also ensures that the metadata is consistent, interoperable, and aligned with domain standards. The result is a more efficient and scalable approach to dataset discovery. eNeos can now identify and integrate relevant datasets faster, with greater confidence in the quality and relevance of the metadata. This accelerates their research timelines, improves the robustness of their analyses, and ultimately supports more effective gene discovery and therapeutic development. In short, LLM-DAP empowers eNeos to overcome the limitations of fragmented data documentation and move toward a unified, intelligent approach to metadata generation, unlocking new possibilities in genomic research. What are today's takeaways from this webinar module? By combining large language models with retrieval-augmented generation, LLM-DAP automates the creation of rich and relevant metadata, making datasets easier to discover, reuse, and integrate across domains. It's especially valuable for small and medium-sized enterprises like eNeos, as shown in the case study. LLM-DAP is lightweight, open source, and user-friendly, helping SMEs reduce manual effort and improve interoperability by profiling datasets using custom metadata schemas. Its flexible pipeline supports a range of tasks, from data profiling and search to exploration, adapting to different domains, hardware setups, and cost constraints. LLM-DAP is a practical, scalable solution for smarter data management. Thanks for joining today's session. If you'd like to dive deeper into LLM-DAP and its applications, we've got some great resources for you. First, you can explore the framework in detail in the VLDB workshop paper. Secondly, you can learn about the empirical performance measures in the Bioinformatics Journal. And if you're ready to try it yourself, the open source code is available at the Syntef GitHub repository. Thank you for attending the webinar.